For our final project, my partner Jackie and I developed 4 different convolutional neural networks for our task of plant seedling classification. As a bit of background, agricultural technology is facing sustainability and productivity challenges in the coming years. We are interested in taking an input image of a crop seedling and outputting its predicted species for applications in the agricultural space. Our dataset contains roughly 5,000 color images of 12 different labeled plant species. For our baseline model, we trained a network with 2D convolutional layers using ReLU and softmax activation functions and a categorical cross-entropy loss. This model did surprisingly well given our small data and achieved 73% test accuracy. Next, the first pre-trained model we tried was DenseNet, which is a 121 layered network. This model achieved a loss of 0.5 on the training set and 62% accuracy.
Hi there! As Madison probably just talked to you about, for our project, in addition to implementing a baseline convolutional neural network, we also leveraged pre-trained networks that have been trained on ImageNet and use those weights to customize these pre-trained networks for our own data set. And so the remaining 2 that we used were VGG16 and ResNet50, both state-of-the-art models. And we found that surprisingly our model actually performed better than the pre-trained networks, which was completely against our hypothesis, but we have some ideas as to why that may have been the case. One could be that our dataset is too dissimilar from ImageNet for these models to perform well. This could be because we normalize the data in a different way, or just because the images are so close up and very specific. Another thing is that a lot of the images are very, very similar, and so a piece of grass looks very similar to this weed called loose silky bent, and so it was very difficult, as you can see in the confusion matrices, for the pre-trained networks to be able to tell the difference between these, leading to a lot of misclassified examples. And our model actually was pretty resilient to those examples, and so we were pleased that it performed better, and despite having a really small data set, our model achieved a F1 score of 74%. And in the future, some ways that we could improve upon this would definitely be more hyperparameter tuning, see if we could get the pre-trained networks to achieve better performances. And we'd also like to look into texture analysis, which we saw in a lot of papers, where the texture is kind of used as a feature to identify the species of leaves. Thank you so much.